still back from what we have been handling. We have been looking at some simple review. We have looked at the rectilinear propagation of light, the property of light which says that light travels in a straight line, and we have tried making some experiment that shows that that can prove that light travels in straight line. And under this, maybe you can go and see more about the application of the linear propagation, like in formation of eclipse. You can look at pinhole camera, okay? Pinhole camera, and then you can look at formation of shadow. All those uses the same idea. Is that okay? Under the linear propagation of light. And then we have come to the reversibility of light. And we say the reversibility of light, it states that if the path of light is reversed, it always follows the same direction. If we reverse the path of light, that if it was traveling from here to here, and now we decide to make it to move from this side to this side, it will always follow the same path. That's what we call reversibility. It can reverse. Is that it? That you can begin from here up to this side, and then from this side up to the other side. Is that okay? And then we had stopped on looking at an experiment to verify that. Is that it? We can look at an experiment to verify that after looking at reflection of light from a given surface. I can have my board on you get a sheet of paper, draw a line, and then that line, the outline of that will be representing our mirror M1. Is that okay? That will be our mirror M1. And then on that mirror, I can draw a normal. Then I can draw a normal at that point. And then on that normal, what happens is I can draw a line at some angle, maybe say there. Is that okay? And then if I draw a line here, I can put a pin here. I put another pin here. I can call this P1. I call this P2. Is that okay? This is the normal at right angle. Is that okay? And then what happens is, as you are observing from this other side here, you come and observe from this other side. You put another pin along or in a line here, such that these two appears to be in the same line with what you are putting. Is that okay? And therefore what will happen is, if you put, you may put, maybe say it will be here and here, because the image of this will come somewhere here, and then the image of this will come somewhere there. Then when you put, it will be something like that. And then if you join, if you join, it will be something like that. That means that this light came and it got reflected in here. Is that okay? You'll see now the image of these pins to be in straight line. The image of these pins will be in line with this one, P3 and P4. Isn't it? Now, what next do you do? What next can you do? Now, afterwards, shift this pin now, and instead bring it on this specific hole. And then on this specific hole, pin 1 and P2, reverse them and put maybe pin 2 here, pin P1 here. Now, instead, come and observe from this other side. Come and observe from this other side. It is very true that when you now put pins here and here, and now you are seeing from the other side, you will realize that for these pins you are going to put, to be in line with this one you have already put, they will still be placed at the same position like for the first one. And that shows that you are reversing the position of the what? Of the pins. Still you're putting them in the same position. That means that the path of light can be reversed. That initially it was traveling from this coming to your eyes. Isn't it? But now you have shifted your eyes in the position 2. You have brought the other two pins side. Now it is traveling from these pins reflected in your eyes. Is that okay? That is the principle reversibility of light. That the path of light can be reversed. Here we are looking at it, the path being reversed under a scenario of reflection. Is that okay? We can also look at it under a scenario of refraction, which will be in our subunit 3. Is that okay? But this is still under reflection. Once again, I said you can get a sheet of paper, draw a straight line where you put your mirror in position M1, draw a normal there. Is that okay? This is our normal. This is the point O. Is that okay? After drawing that normal, put 2 pins. Is that it? Put 2 pins, maybe P1 and pin P2. And then come this other side and put pins from this other opposite side. Put pin here and here, such that it appears to be in line with the image of this and I told you the image of this will come here. The image of this will come somewhere down here, such that when you're putting this, the 4 will look in straight line, therefore it will be like this. And what is the path of light in that case? That means that light was traveling from these 2 pins, reflected here in your eyes. That's why you're putting these 2 pins. That means that the direction is this, and then this in your eyes. Is that okay? And then I said, again, you can now remove these pins from here. Is that it? Remove all the pins. And now begin by putting the pins instead on the other side. Is that it? Begin now with the pin P1, P2 here first. Is that okay? Put pin P1, P2 here first. And now instead of observing from here, come and observe from the other side. What is true is that the image of this will be here, the image of this will be here. So when you're putting pins, you will realize that the pins will go in the position of the first one in order to be in straight line. What does that mean? That light is going to follow the same path, and that's why the pins were replacing themselves in the same position. And it will be traveling from now this direction as it is going to your eyes. So that means that the path of light is reversible. That it can travel along the same light to your eyes, or from this side again the other side. So that is the proof for the principle reversibility of light. Is that okay? And then let's go to our new idea of reflection. Reflection. Reflection of light. Let's look at what we are calling reflection of light. What is the reflection of light? If you hear the word reflection of light, what basically comes into your minds? If we say reflection of light, who can define for us what a reflection of light is? Reflection of light can be defined as the bouncing back of light rays after meeting a shiny surface. Is that okay? The bouncing back of light after meeting a shiny surface. That if the light goes and finds a surface and now it comes back, the coming back of the light after meeting a surface which is shining, we call that one reflection of light. Is that okay? It can reflect in the same path or in a different direction depending on the angle of instance of the light. So when we say what is reflection of light? Reflection of light is the bouncing back of light after meeting a shiny surface. Is that okay? And then let's look at the laws of reflection of light. Laws of reflection of light. Actually, before looking at the laws of reflection of light, I would basically maybe brief you through some few terminologies that we're going to be looking through under the laws of reflections of light. And that is, considering this ray diagram, I can say this is my normal, this is point of incidence on normal, and then I can have this, if this is reflected like that, this is I, this angle is called R, and this angle is called G. So this is A, this is B. Using that diagram, let's first look at some few terminologies that will make us understand the laws of reflection, or we can use to state the laws of reflection very well. So, what is the line AO representing? That is the incident ray. Then AO is the incident ray. And then we can also look at the OB, which is the reflected ray. Is that okay? And then we can also look at the ON, which is the normal what? Normal line, not normal ray. It is a normal line. We don't put arrows on it because it's not a ray. It is the normal line. This is the incident ray, the reflected, and the normal. And then let's look at the angles which are involved. We have angle I, which is called the angle of what? It is called the angle of what? Angle of incidence. Okay? Angle I is the angle of incidence. Is that okay? It is the angle between the incident ray and the normal. That is, if at all they ask you to define the angle of incidence, the angle between the normal ray, the incident ray and the normal line. The normal is not a ray. It is the angle between the incident ray and the normal line. The incident ray is this, the normal is that. The angle in between is what you're calling angle of incidence. And then we also have angle R, which is called the angle of what? It is called the angle of, who can tell us? It is called the angle of reflection. It is the angle of reflection. That when the ray is reflected, the reflected ray and the normal makes an angle called the angle of reflection. Is that okay? Good. That is what we call angle of. And then the point O is what we are calling point of incidence. The point of incidence, where all the incident, the normal and the reflected, all of them meet at a single point. We are representing with the letter O, and that's what we're calling point of incidence. Is that okay? And then maybe we can also add another thing here. We are calling angle G. What is angle G on our diagram? Angle G is called the what? Is called the glancing what? Glancing angle. Glancing angle. What is a glancing angle? From the diagram, what is our glancing angle? The glancing angle is the angle between the incident ray and the reflecting surface. That if the incident ray is this and the reflecting surface is this, the angle between those two is what we are calling angle of incident. Glancing angle, I mean. It is what we are calling glancing angle. Angle between the reflecting surface, this is the reflecting surface, and the incident ray. That angle is what we are calling glancing angle. And then we can also look at some other thing as angle D. From our diagram, angle D, we have what we're calling angle D. Angle D. What is this angle D called? That is what we are calling Angle of what is? Angle of deviation. Angle of deviation, isn't it? Angle of deviation. How do we define the angle of deviation? Angle of deviation is the angle between the initial direction of the light rays and the final direction, isn't it? That initially this light, if it was not to change direction, it was meant to move this direction, isn't it? But because of this surface here, it changed the direction, isn't it? So initially it was moving here, it changed now. What is the angle between the initial direction and the final where it is going? Is what we are calling angle of deviation. Is that okay? So the angle of deviation is the angle between the incident ray. Angle of deviation is the angle between the initial direction of the light rays and the final direction. The initial and the final. That is what we are calling angle of deviation. What is deviation alone? If you just say not angle of deviation, what is deviation? And I'm now saying angle of deviation. What is deviation? In simple understanding. Deviation is the change in the direction of light rays. It is the change, it is not an angle. Is that okay? That if light was moving here, now it is moving there, we say it has deviated. But it has been deviated through some angle, and of which the angle is given by what? Is given by the initial and the final direction. Is that okay? So basically these terms here will help us to mention a lot. We shall be using them under the reflection of light. Is that okay? Good. Then now we can go back to our laws of reflection.